This is the third part of this section. Real quick, I found out what my mistake was here. I did not round it correctly here. It's 0.003, or you can use 0.0025. That changes this to 0.021. That was my major mistake. Now they would be exactly the same because now this would be 0.022, which is exactly what we got on the last one. So sorry about that. Just a quick little mistake there. When it comes to it, my rounding was a little off. But again, that should be exactly the same. So that was my mistake there. Okay. All right. So now moving forward to go to question 5 and then to question 6 as well. Question 5. So again, once you guys try questions 5 and 6 yourself. So I'll give you guys a 3, 2, 1. Try these out using the same tempo we did above. 3, 2, 1. Pause. Okay. All right. So hopefully you guys did them, and hopefully you guys had a little trouble with question or part B or double B there. This is a good one, right? This is the one we actually definitely want to talk about there. But let's just try these out first. If this size of focus, perfect. All right. All right. So same situation, right? We still want 5, so this is going to be probability of exactly 2. So this is 5, choose 2. Okay. Now, since we want success to be people who have blood type O, and that's going to be 0.45%, so this is 0.45. So therefore, failure is 0.55, right? And this is going to be to the 5 minus 2 power. Okay, so breaking this down, hopefully you guys got a grand total of 0.337. Okay, so if you didn't get there, I can just quickly go down through it. So 5 choose 2 is 10, and then 0.45 to the second power, 0.202, and then 0.55 to the third power, 0.166, right? And then just multiply them. You should get 0.337 as your answer. Okay. All right, so now let's go to on the first B. For some reason, it's supposed to be a C part there. Okay. So for the first part B, find the probability of at least 4 of donors have blood type O. Okay, so why don't we just do a little table? So just like we did last time, 0, 1, 2, 3, 4, and 5. Now for part A, we found 2. That was 0.337. Now we want at least 4. All right, so going back to our page, what does at least 4 mean? So remember, so if you always ask me on the questions or in the homework, what does it mean? I'm always going to say, well, go back to page 75, right? It's the reason why I gave you guys this portion. So at least is right here. So that's saying there, x is greater than or equal to the number. Therefore, over here, we have x is greater or equal to the number 4. So we want 4 or more. So we want to find what 4 is and also what 5 is, right? Because that's 4 or more. So essentially, this probability is breaking down to I want 4, then plus the 5. So notice this is the same thing we did in 5.1, right? Given the chart, can you find what's given to you? The only difference is now the whole work is constructing it, then just adding them together, okay? All right, so let's do this really quickly. So we want 4 or 5, so we have to do this twice. The probability of 4 and the probability of 5. Okay. So this is 5 choose 4, 0.45 to the 4 power, 0.55 to the 5 minus 4 power. And down here, this is 5 choose 5, 0.45 to the 5th power, 0.55 to the 5 minus 5 power. Okay. Right. Okay, so if you do this respectively, right, so hopefully if you do the first one, you guys got 0.113, and for 5, you should get 0.018. Okay. So let's just put this here for our case. So this is 113.018. Okay. So our answer, right, is now the sum of these two because that's what we want, right? 4 or more. So if we add these two together, that's going to be our true answer we want for this question. So a grand total of 0.131. So that is the probability of at least 4 donors having blood type O. Okay. Now let's go on to C, or the C I changed it. So find the probability of at least 1 of the donors have blood type O. Okay, at least 1. So again, we're doing at the at least. Well, looking at a chart, at least one means x is greater than or equal to the number. So here we say x is greater or equal to 1. That's what we're looking for. All right, so we want this probability. Now, let's go back to our table here when it comes to it. So focus. There you go. So let's look at a table here. So this says, right, x is more 1 or more. So I want 2, 1, 2, 3, 4, and 5. So I'm adding all of these numbers. But here's the problem. I don't have them. Because if we did A and B, we have 3 out of the numbers we have. But we have to do it once for a 1, and then again for 3, and then add them all together. However, what do you guys think would be an easier way to deal with if we actually didn't have these for part A? Give you a hint, something called the complement we talked about earlier. So essentially, what's another way to write this probability using complement? Okay. So let's see. So here's the probability what we want. Now the question is, what is the complement? So what is everything that's not in here? Well, if we look at our table, what's everything that's not associated? 0. So the complement is literally when x equals 0 must equal 1. So again, right, just doing a basic algebra proportion, just solving for this portion, subtract this over, this is equal to 1 minus the probability of 0. So the thing is, right, you don't have to do it this way. But, when it comes to math, you always want to, not try too hard, always think smarter, not harder, right? So essentially, you can literally brute force your way through this, do this 2 more times and add them all up, okay? Or you can do the slick way and just do 1 time and subtract it from 1, because that's, if I subtract this from 1, that's everything I actually want as well, right? So remember, complements means they're equal to, they're completely independent of each other, meaning they just cut off itself. So it's going to be the top plus the bottom must equal 1 itself. Okay? So if we do this portion, makes it much easier. All we have to do instead of doing it twice more, you just do it once and then subtract it from 1, and we're actually done. So essentially, this becomes what happens when x equals 0. So that's 5 choose 0. 0.45 to the 0 power, and then 0.55 to the 5 minus 0 power. Okay. All right, so we do this, it's going to be 1, it's also going to be 1, and essentially all we care about is what's 0.55 to the 5th power. Okay. So 0.55 to the 5th power should give you 0.050. Okay. So if I go back to my chart, this is now 0.050. Now if I do 1 minus this, that gives me everything I actually want. So again, right, if you're not sure what I mean by that, always go back to the horse example we did in 5.1. How would he solve for symbol x? Well, add them all up, plus the x must equal 1 by portion. Same thing applies here. I want all of this, I have this, subtract it from 1, gives you everything we actually want. Remember, we don't care about the individuals. We want the entire sum because I want everything more than 1. So I want this entire sum, not the individual values in this case. Okay? So our true answer, which is exactly here, is going to be 1 minus 0.050, which should give you 95%. So 0.95. And there's your answer. Now, let's suppose you really want to brute force your way. In other words, find the other 2 values and sum them up. Well, let's do that. Now, I did it already for you guys, so if you guys want to try it out, so if x equals 1, you should get 0.206. And when x equaling 3, you should get, my notes, 0.276. So if I want to add each one individually, so that's going to be 0.206 plus 0.337 plus 0.276 plus 0.113 plus 0.018. If you add them all up, that should give you 95 as well. So go ahead and check. And there you go. It gives you exactly 95. So there's 2 different ways to do these problems. However, right, there's one way, the brute force, you just go through it, and there's a slick way corresponding to it. Now, most cases, you kind of want to do this because, again, especially on exams or homework, you don't want to do those portions, especially when x is going all the way to like 15, right? They kind of emphasize you do not want to do this 15 times. You want to go the back way and just subtract the complement itself. So on your homework, there'll be some questions, outrageous, x going all the way, to 20, and then, want to find what's the probability of at least 1. Well, they're not trying to make you do, 18 different times or 20 different times. They want you to understand, okay, you just do 1 minus the 0 portion to give you what you want, because you want the sum, not the individual portions in this case. Okay, so just a quick little warning for your homework. Again, right, so things like that. All right, and then the last one for question 6. So based on a Ridge survey of college students, 25% of college students plan to choose a career in information technology. Find the probability that among 24 randomly selected adults, say exactly 6, choose a career in information technology. So this one should be pretty straightforward, right? X equaling 6. N in this case is now 24, so much higher, right? Success, so probability of someone actually choosing a career in technology is 0.25. And then Q is going to be 0.75. Okay, so this is going to be P6 is equal to, so 24 to 6. And then it's going to be 0.25 to the 6 power, 0.75 to the 24 minus 6 power. Okay, so let's see. So 24 to 6 is going to be a pretty big number. Point 0.25 the 6 power. It's a very small number. And then 0.75 raised to the 24 minus 6 should give you, I believe, 18. So 24 minus 6 is 18. Should give you 0.00, let's say 6. Okay. All right, so now multiplying these all together. Gives you 0.162. Okay. And there you go. Okay. All right, so like I said in the first scenario, I'm going to give you guys a scenario when this is, failure itself. So let's suppose we have a part B to this question. Okay, so the part B question asks you, so find the probability that among the 24 adults, 8 do not plan a career in information technology. So now this is do not, so we want the opposite, so don't want, okay? So in this process, X is going to be 8, and it's still the same, 24. But now in this case, we got to find what P and Q is. Okay? Now, based off this information, if I want do not plan, so therefore 0.25 is now failure. Okay? Because that's people who do want to go into information technology. So this is actually failure, people that actually go into technology. So therefore people who do not go into information would be 0.75 now. Right, notice now it's the opposite of what we actually have. Okay? Because of that, again, you always go back to what the question is asking. I do not want people to plan it. So therefore, again, success is how you actually incorporate the question. So this is now people who do not go into it. This is now people that do go into it. So that's when by success or failure, one or the other. Okay. So in this case, 0.8 would be 24, choose 8. Success, 0.75 raised to the 8th power. And then 0.25 raised to the 24 minus 8th power. Okay. So quickly finishing this up. It was a super small number. Essentially 0. So just say super small. There's a 10 before it. So this is 2.3 times 10 to the negative 10. So there's 9 zeros before it. And then finally multiplying this all out. There's your answer there. Okay. So that's the probability of 8 people do not plan to attack a career in information technology. Okay. All right, so that's it for this video. Hope you guys have it.